Okay, so we're going to look at some algebra review that's going to be helpful for this, all of geometry as a whole, because there's going to be lots of different algebraic equations that we're going to solve as part of it. So let's just start with some basic fractions. As a reminder, if we're going to add or subtract fractions like in A or B, we need to have common denominators. So for 3 over 4, for example, I can multiply this by 3 and 3. So that becomes 9 over 12 plus 1 over 12, which is 10 over 12. Now, 10 over 12, I can reduce that down. So with fractions, I do want to reduce them if there's common factors. So for example, if I divide by 2 and divide by 2, I get a final answer of 10 divided by 2 is 5, 12 divided by 2 is 6. So 5, 6 is my answer. For the next one, 4 minus 5 thirds. Again, I can make this a 4 over 1, and I want to make it over 3. So I multiply by this by 3 and 3. I get 12 thirds minus 5 thirds. 12 minus 5 is going to give me 7 thirds. And I'll just leave it like that. Multiplication, same thing as before. I want to make this 5 over 1. When I multiply, I could just multiply across as long as there's no common factors vertically or diagonally. So what I mean by that is I'm looking at 2, 1, 5, and 3, 5 and 1, 2 and 3 like that. There's no common factors in any of those cases. So 5 times 2 is 10, 1 times 3 is 3. For division, in order to do division with our fractions, we're going to first turn into a multiplication problem. So this is going to be 3 over 2 multiplied by 8 over 5. Now, I do have common factors with 8 and 2. So if I divide by 2 is 1, divide by 2 is 4. Now I just multiply across. So 3 times 4 is 12, 1 times 5 is 5. Solving linear equations for example 2 here. Whenever I'm solving equations, for a case like A here, I like talking about undoing the order of operations. So when I look at x is being multiplied by 2 thirds and then added by 3. So I'm going to start by subtracting 3. We're going to undo these in reverse order. 13 minus 3 is 10. And then I want to undo the 2 thirds. Now this is multiplying by the 2 thirds fraction. So remember, I can multiply by the reciprocal to undo that. So it's kind of like dividing with the fractions. I multiply by its reciprocal. So this turns into x. And then I have 10 over 1 times 3 over 2. And then I've got 2 and 10 have a common factor. So divide by 2 is 1. Divide by 2 is 5. 5 times 3 gives me a final answer of 15. Part B, this is going to be solved using cross multiplication. If I have a fraction equal to a fraction, we are going to cross multiply like this. So it's going to look like 4 times x plus 3 is equal to 6 times x minus 1. So that I can distribute the 4 and distribute the 6. So 4x plus 12 equals 6x minus 6. From here, I want to get common factors, or like terms together on the same side. So I can do that by subtracting 4x to both sides, as well as adding 6 to both sides, because 6 and 12 are like terms. This will get rid of the x on the left side. It's going to get rid of my numbers on the right side. So 12 plus 6 is 18. 6 minus 4 is 2x. Then divide both sides by 2, so I get 9 equal to x. Solving quadratics by factoring. So if I do factoring here, just a quick version of this, it's going to look like this. X squared has to come from x times x. 12 and 7 is got a certain pattern to it. That pattern is what multiplies to 12, and then you might see it like this, and then what adds to 7. So the two numbers that do that are 3 and 4. So x plus 3, x plus 4. Now for solving, I make it x plus 3 equals 0, x plus 4 equals 0, and then I subtract 3 and I subtract 4 to get my final answers of -3 and -4. For the next one, before I can do any factoring, I want to bring everything over to one side so it's equal to 0. So I'm going to subtract 8x over and subtract 6 over. So 2x squared minus 1x minus 15 is equal to 0 now. With this kind of factoring, it's a little bit trickier because of the 2 here, but I still kind of use common sense. The only way for me to get 2x squared is got to be a 2x and an x. Then I have a -15 here with a -1. So I'm going to say it's probably going to be a -5, -5 and a -3. Yeah, sorry, it'll be a -3 and a +5. Because when I multiply this out, when I go backwards, like a guess and check, this multiplied out is a -6x. 5 times x is a +5x, which comes out to a -1x, and that's what's in the middle. So now I can say 2x plus 5 equals 0, x minus 3 equals 0, and then x equals 3, and then this one, I'm going to have 2x equals a negative 5, and then I want to divide by 2, so I get a negative 5 over 2. Another way of solving our quadratics is using the quadratic formula. Basically, if I have a, b, and c right here for 3, 4, and negative 2, that can follow into this formula in these patterns here. So that means I'm going to do x is equal to the opposite of b, so it's a negative 4, plus or minus the square root of 4 squared minus 4 times a, which is 3 in this case, times c, which is a negative 2, all over 2 times 3. So now it's just a matter of doing everything step by step. So for example, I'll do inside the square root symbol first, so 4 squared and these together, so I'll have negative 4 plus or minus the square root. 4 squared is 16. Let's see here, this will be negative 2 times negative 4 is positive 8, times 3 is a positive 24, and that's all over 6. Then I have negative 4 plus or minus the square root of 20, 30, this will be 40 over 6. And I can simplify the square root of 40, but I'm going to leave it like this for now because we're going to talk about simplifying radicals down here. All right, next one is solving systems of equations. Yeah, so solving systems. Honestly, we're going to skip that for now. We're not going to worry about example 5, but let's talk about simplifying radicals real quick. So simplifying radicals means we are looking for common factors that can divide out to make these into smaller values. So for in this case, I mean with 36, this is a 6 times 6. So the square root of 36 is finding what two numbers multiply together to get me 36. Well, since 36 is 6 times 6, that is just going to be an answer of 6. With 50, that's a little bit harder. If I split this up, I could do 2 times 25. 25 is made up of a 5 and a 5. So that's my square there. That's my numbers multiplied together. But I have an extra 2 here. So what happens is every time I have a pair of factors inside the radical, I can take that out and make it a whole number like this. And then on the inside, I'm going to keep the square root of the number left over, which in this case is 2. So you can do that with any sets of numbers. You can just break them all down, and what you're going to look for is just pairs. As long as there's pairs of numbers, like 2 of a kind, you can then take those out of the radical. So for example, 360, that's 36 times 10, and 36 is 6 times 6, so there's my perfect square. 10 is 5 times 2. And then I cannot break down 5 and 2 anymore. That's as low as it gets. So that's actually done at the 10 mark. So what I get here is 6 is going to come to the front. Square root of 10 stays on the inside. So we have a 3 root 96. We're going to do the same thing here. This is the same as 48 times 2. 48 is 6 times 8, and here's a 2. And then this will be 3 times 2, 2, and 2, and 2, and then one more 2 in the end. Okay, so you can take a little bit of shortcuts. Like for example, with the 8, I know that's 3 2's multiplied together. So I just did all 3 of those like that. So we're looking for pairs of numbers, so 2 of a kind. So everything here is inside the radicals. We have 2 2's, and then a 2 and a 3 left over. So what that means is the 2 2's come out front. So I'll have a 2 and a 2. But don't forget about the 3 that's already in front. So I have a 3 times 2 times 2. And then I have a square root of this 3 and this 2 go together. So 3 times 2 is going to give me 6. So simplify a little bit further. I have 3 times 2 times 2 is going to give me 12 radical 6. So this one's a little bit tougher. We got 9,072. So I want to find a, let's see here. So 9,072, okay. Let's try, let's see here. If I divide it by 2, that's 45, 36. Let's see here, divide by 2. I'm going to take a little bit of a shortcut. We can do 4 times 2268. And divide it by, no. Divided by, let's try 4 again. Yeah, we can do 4 again. So we have 4. This is going to be 4 times 567. Let's see here. If I divide that by 9, so 567 divided by 9 is 63. There we go. We got 4 times 4 times 9 times 63. And then from there, I can do 63, can break down again. That'll be 9 times 7. And so what I have is I have a pair of 4s and a pair of 9s. So those are both going to come out. So it's going to be a 4 times 9 on the outside. 7 is going to be left over. So what I get is 36 radical 7. Okay? So like I said, we're not going to worry about the systems of equations, but everything else we covered is going to be important for geometry for in terms of algebra. So make sure you understand how to do these problems. And after that, you can be working on the rest of these examples as homework. So we'll spend some time more time on that in class. But that is it for today. So take care, everybody.